Hello class, welcome to the next section of our studies on function. Today we are going to learn or work on the domain of a function, which is mainly on the understanding the input restrictions in function. So understanding input restrictions in function. Every function have an input restriction. A restriction on what to do and how and what the function accepts. So first of all, what is domain? The domain of a function is the set of all possible values of x for which the function is defined. The x that we are talking about here is the input, the object which we are looking forward to see its image or their image. In simpler terms, it is the set of x values that you are allowed to substitute into the function without causing errors. What can restrict a domain? Because we don't want to cause an error to a function. So the restriction, if we don't want to cause error to the function, will be in the form of division by 0. So anytime you are dividing by 0, it will be undefined. That is, it means that we are going to get an error when you divide by 0. And the division by 0 exclude the s values that make the denominator goes to 0. It means that whenever I have division, I can divide or work or express the function in any s values except any s values that will make the denominator goes to 0. The restriction number 2 can also be on even root, like square roots of negative numbers. And square root of negative numbers under the root sign are not real, they are complex. So it restricts the expression inside the root to be greater than or equal to 0. So if an expression is under a root, the restriction is such that we should have the expression being greater than or equal to 0. Then we can also talk about logarithmic functions, and it must be a positive input. Then let's talk about domains by function types. So we are going to learn about the kind of restrictions that will be put on other function types. So the function types that we are going to work on generally are polynomials, rationals, radicals, logarithmic functions, and exponential functions. So let's note and understand how each of the function is being expressed. Look at the example of the polynomial function, example of the rational function in the form of a fraction, example of a radical function, that is where there is an expression under the root sign, example of logarithmic function in this form, an exponential function. Look at the example where the input variable will be the exponent or the power or the index. Let's work on the polynomial functions domain. Here we are going to understand the general domain or the general set for a polynomial function. For a polynomial function, you can plug in any real number. There are no restrictions like division by 0 or square root of negative numbers. Example of a polynomial function is f of x equal to 2x squared plus 3x minus 4. So when you have this particular polynomial function, if you want to write a domain, then the domain will be all polynomial functions are defined for every real numbers. So it means that the x can be x. Let me put it in this way for you. The x will be any real number. It means that we can't have a particular restriction on this particular function, because any s value that you input here is going to result in a unique output. There is no s value that will put this function in an error form, that will restrict the function in an error form. So that means that the domain is written as x is said that x is a member of all real numbers. That is, x is defined for all real numbers. So that is how we can write the domain for this particular function. Look at the graph side, or the graph inside rather, of this particular function. There is a sketch of the graph of f of x equal to x squared minus 3x plus 2. For this particular graph, it is very smooth and has no break. If you look at the graph, it starts from the left side and moves to the right side, and there is no break between the graphs. So the graph is a parabola, and it continues left and right without stopping. That means that we can plug in any value of x without, or whether it is negative or 0 or positive, without the graph being breaking. So the domain is all real numbers. There is no s values that made this particular function undefined. It means that there's no restriction on this particular function. We can also talk about rational function, which is also in the form of a fraction where the numerator is a polynomial function. The denominator is also a polynomial function. The domain includes all real numbers except those that makes the denominator 0, because division by 0 is undefined. We have to know that. We must exclude those s values that will put the function into an error. So here, when we want to find the domain of a rational function, we put f of x to be not equal to 0 and solve. So example of a rational function is in this form, that is x plus 3 divided by x minus 5. We make sure that we identify the denominator as x minus 5, and that is it. And the denominator will not be equal to 0, so we make the x the subject. So when you make x the subject, to be x not equal to 5. So if I want to write a domain, it means that I can use any kind of input from the real numbers to have, and that will give me an input, but I will not be able to get an input and an output or an image for the input 5. It means that the restriction on this particular function is such that we can, this particular function rather, is such that we can't use 5 as a substitute for x. Another example is here, that is example 2. The same scenario here. The input can be any real number with the exception of plus 2 or minus 2. Why? Because plus 2 will put the function into an error form, and minus 2 will also put the function into an error form. Let's look at the graph view of rational functions. So on the graph, there will be a vertical asymptosis at values excluded from the domain. So when you look at this particular rational function, the value which is excluded from the domain is 2. So you are going to see asymptotic movements of the function closer to the 2. It will be like it is going to intersect or be on the 2, but it will never be on the 2. So you are going to realize that there will be a break. Look at the break here. This is the s equal to 2, and that is the asymptotic line to the left, and an asymptotic graph or function to the this one is to the right, and this one is to the left. So you realize that the denominator, you realize that uh, the function will get closer to x equal to 2. So here, x is equal to 2, the denominator becomes 0, which is undefined. That is why the graph has a break called an asymptote. So the asymptote is at x equal to 2. So the domain is all real numbers with the exception of 2. It means that when you see a graph like this, the domain is the real numbers on the right side here, and the domain is the real numbers on the left side here, with the exception of x equal to 2, which means that at that point the graph will break.